go to the next problem related to an RH criteria. So in the previous problem which we have seen how to find out the range of k for the system to be stable, and how to find out the omega for sustained oscillation. All those things we have seen in the previous problem. Now we will see another problem which is not meant for finding out the range of k. It is a normal problem where we see where we find out the roots and then we decide whether the system is stable or not. Okay, so that is the second problem which we are going to do it, and we will also see certain conditions that we we will be seeing certain issues in RH criteria, and whether we need to solve it or not. Let us see that those conditions, whether it will come in this particular problem. Okay, now s power 6 plus 4 s to the power of 5 plus 3s to the power of 4 and plus minus 16 s square, then you have minus 64s, and then we have minus 48 equals 0. Minus 48 equals 0. So this is a given question, means this is a given means they have already given you the characteristic equation in this particular problem. So you need now to find the characteristic equation what we did in the previous problem. So this is the given equation to you. You need to find out whether it is stable or not by finding the number of sign changes, whatever it will happen. So in the earlier problem we did not see any sign changes. We found the range of value of k to consider the system is stable. So within that range of k the system is stable. So if k is less than 0, or if k becomes greater than 3.36 in the previous problem, we saw that the system would become unstable. Okay, so in that case let us also see whether what condition that we will be able to see in this particular problem. So now the first job for me is to, as I said you, is to construct the Routh array, because already given the characteristic equation, so we are directly finding out the Routh array construction in this particular problem. Okay, so we need to construct the Routh array here. So for that we need this table that we form. So this consists a row and column of Routh array. So now let me write the terms. Now it will start from s power 6 here. So therefore I'll write s power 6, s power 5, s power 4, s power 3, then s power 2, then s power 1, then s power 0. Okay, so these are the terms which you see in the vertical way of writing. Now as I said you, when it starts from s power 6, we are going to write the coefficient of s power 6 is 1. Okay, so the coefficient of s power 6 is 1. The coefficient of next even number is s power 4. So you need to see the even power here. See, 6 after 6 there is 5 which is not even. So 4 is even. So write the coefficient of 4, which is s power 4 is 3. Okay, so that is 3 actually. So 3. Then we do have a coefficient of just write it for so that I will get some space later. So now then we need to write the coefficient of next even number. See, there is one thing which you need to see in this particular problem. See, we have s to the power of 4 term, but we don't have s to the power of 3 term here. Okay, immediately it went on to s square. So therefore, as s power 3 term is not there, the coefficient of s power 3 term is 0. Keep that in mind. Okay, but anyway, after 3, which is the coefficient of s power 4, the next even is s square. So we will write minus 16 is the coefficient of s square, so minus 60. Now the next coefficient would be the coefficient of s power 0. So coefficient of s power 0 is minus 48. Polarity also should be considered, not just the value. So if it is plus 48, then it would be plus 48. Now it is minus 48. So we will also take the negative value here. So this is the s power 6, s power 4, s square, s power 0. Okay. Now coming to s power 5, next row which we are going to construct here. So here s power 5 coefficient is 4. Okay, so you write here 4. Whereas s cube is what the next odd number. Okay, as we don't have in the equation, we consider the coefficient of that to be equal to 0. Okay, so s cube is 0. Now after s cube, the next odd number is s power 1. So therefore s power 1 coefficient is minus 64. And after this we don't have any other coefficients, because the last coefficient itself is s power 0. Therefore we will write here the entry is 0. So these are the two rows which we construct through looking into the array, looking into the characteristic equation. Now the next rows should be found by us. According to the previous problem which we did, you have to do in the same way even this problem also. So let us write line by line. Let us do the calculation one by one. So here 4 into 3, 12 minus 1 into 0 divided by 4. Okay, so it is 4 into 3 is 12, minus 1 into 0 is 0, divided by 4. So it is 12 by 4, which will be giving you 3. Okay, so therefore the entry of this row, first element is 3. Coming to the next element, it is 4 into minus 16, 1 into minus 64. So here minus 16 into 4. So minus of minus 64 into 1 divided by 4. So what is 64? 64. So it is minus 64, minus of minus plus 64 by 4, which is equal to 0, because minus 64 plus 64 is 0. So it is 0. Coming to this element, whatever here is 4 into minus 48, 4 into minus 48, minus 1 into 0 is 0, divided by 4. So you will be getting minus 48 here. This is minus 48. Okay, and you don't have any other elements after this minus 48 and 0 here. So this will become 0. Okay, now this is the next row which we have constructed in the Routh array. So let us go in calculating the next row in the Routh array. I don't know why it is becoming. This row is over now. Now let me construct this row now. Yes. 4 into 0 minus 3 into 0 is 0. 0 divided by 3 is 0. So you are getting this as 0. Okay. So this element is 0. Now here the problem will arise. I will tell you what is that. Now coming to this element, 4 into minus 48, 4 into minus 48, minus of minus 64 into 3, divided by 3. So divided by 3. So what we will get here is 64 into 3. That is the positive term which you get. So if you calculate this equation, so you get 64 into 3. 64 into 3 equals 192, minus 4 into 48 equals 0. See, 64 into 3 is 192, 4 into 48 is also 192. This becomes plus and this becomes minus, and both when they are multiplied, even this is becoming 0. and this element as it is 0, this is also 0. Now this is the problem what we are able to see. Okay, so what is the problem? So the problem is this row, whatever you see here, has become all zeros. This is condition 2. See, there are two conditions that we come across in RH criteria. Case 1 is any element of first column of Routh array is 0. Any element of first column second element means, see, we don't worry about this element being 0. Okay, this element being 0 we don't worry, but from second element of the first column is 4 3 0. Now from here it will start, okay. So from here to here no element should become 0. The reason is, whenever I am finding out the new value in the next row, every time we see that we are dividing by the element of the first columns. Okay, the elements of the first column is what we are going to divide every time. See, earlier we divided by 4 to find out the third row. When we are finding the fourth row, every calculation will be dividing it by 3. Okay, so anything divided by 0 will become infinity. Anything divided by 0 will become infinity. So that is the problem. So once it is infinite, then what happens here is, if any element after the particular row becomes infinite, we will not be able to construct the further rows of the Routh array. That is the problem. So therefore there are two cases which you see. One case is only, see, in this case this becomes 0 and other two elements are non-zeros. That is the case 1. Okay, then we need to do some mechanism. Okay, but in this particular problem we got with case 2. We saw case 2. What is case 2? In case 2 you see that all the elements of the particular row becoming 0. So once you see all the elements of any particular row is 0, then further constructing the Routh array is not possible. So in case 2, what? All elements of a particular row is becoming 0. So what we will do? So we got this case 2, because this is the problem what we see in this particular problem now. So what we will do when we see case 2? So what we do is, we go with the previous row and construct the auxiliary equation. And then what we do, we differentiate. So the first step is we construct the auxiliary equation, and then we differentiate this auxiliary equation. We differentiate the auxiliary equation. Now whatever the differentiated term is obtained, now the coefficients of this auxiliary equation will be the entry for the row with zeros. So the coefficient of the auxiliary equation will be the new entry. Let me say it is a new entry, because you are replacing 0 with these zeros with the coefficients what you get from the auxiliary equation, differentiated auxiliary equation. Okay, so now what would be the auxiliary equation here? See, this is what the auxiliary equation. See, where exactly you see the auxiliary equation means the row what you get all zeros, right? The row which is previous to that row is what the auxiliary equation row that we consider. So here 3 into s to the power of 4 is what we can see here. So the auxiliary equation would be 3 into s to the power of 4 plus 0 into s square, 0 into s square, because you have 0 here. So that is the, see, every time I told you it should be even number. So s to the power of 4 multiplied gets multiplied with 3 means the next even number is s square. The next even number is s power 0. So therefore it is minus 48 into s power 0 equals 0. So this is your auxiliary equation that we have written now. Okay. Now if I write this equation properly, I will get 3s to the power of 4 minus 48 equals 0. Now let me differentiate this particular equation. I will be getting 12s cube is what the equation what you get, 12s cube. So now what I will do is I will erase this. Erase these terms which are, see, you need to write a new array. Anyway, I am just erasing it and writing it here only. But your job is to construct a new array here. So here the coefficient of s cube is 12. So I will write 12 here. And all other coefficients are again zeros. Okay. Now my job is to construct next row. Okay, next row. See, we are considering only the first column. So first column should not become 0. If first column element is not 0 and all other elements are 0 means you need not to worry. Nothing is problem here. Now coming to constructing the next row. Okay. Now s square. Now here again you see 3 into 0 is 0. 12 into 0 is 0. Minus 3 into 0 is 0. Divided by 12. The element here becomes 0. The element here becomes 0. Whereas the element here is 12 into minus 48 minus 3 into 0 divided by 12 will give you minus 48 here. Okay, so it is 12 into minus 48 minus 3 into 0 divided by 12 only. So here 3 into 0 is 0. Okay, so 12 gets cancelled. So you are left out with only minus 48. Now there is another problem. We saw now the case 1 here, because the first element of that particular row which lies in the first column is 0 and others are non-zero elements. So what should I do here? Okay, so this is the condition of case 1, and what we do is what I am going to explain to you when case 1 will come into picture. So in case 1, any one row, if any one element out of first column is 0, we will replace that element with epsilon. We will replace that element 0 with epsilon, and then we will find out what is the value of epsilon. Okay, we will find out what is the value of epsilon. So now this is the epsilon. Now we construct the next row with this epsilon is considered here. Okay, so epsilon into 0 is 0. Okay, so next row by see 0 is just replaced with epsilon, that's it. So therefore this is what we do in case 1. Keep this in mind. Once you get 0, just replace 0 with epsilon. So there are two methods for case 1 again. Two methods for case 1. So either replace 0 with epsilon, or what you do is you take the equation, okay, you take this equation and replace s with 1 by z. Replace s with 1 by z and construct a new characteristic equation in terms of z. In terms of z. Okay, so that is possible, means you can do that. But the problem is this 0, whatever I got, is arised after the auxiliary equation construction. So we have both the cases in a single problem. So better avoid substituting s as 1 by z in this type of particular problem. Okay, better you go with epsilon. Okay, now if I keep 0 as epsilon, what would be the next two elements? Okay, that is what our intention is. So epsilon into 0 minus of minus 48 into 12 divided by epsilon. So this becomes 48 into 12. 48 into 12 is, let me tell you, 12 into 48 is 576. So this element, whatever we have, this s power 1 element will become 576 by epsilon. Okay, 576 by epsilon, whereas this s power 0 element will now be what is that? 576, and this element is 0 actually. So here 576 by epsilon into minus 48 minus epsilon into 0 is 0 divided by 576 by epsilon. So this 576 by epsilon, 576 by epsilon is cancelled. So you will be getting minus 48. So the last element what you have is minus 48. So if I want to judge on the stability now, if I want to comment on stability now, it's very simple now, because we constructed the whole elements of the first column of the Routh array, which is very much required to comment on stability. Okay, so what we do is, here epsilon should be greater than 0, then only the system is, then only we can say that these two values are positive. So these two values are positive only when epsilon is greater than 0. Only when epsilon is greater than 0, we see that these two values are positive values. But the thing is, you see the last value of the first column of the Routh array, it is minus 48. So if you consider epsilon is greater than 0, this element is positive, this element is positive, but the problem is you have one sign change here, because this is plus and this became minus here. So therefore you have one sign change, So here, if there is one sign change, it means that there is one root, or one pole lying in the right half of S plane. So system is unstable. So the condition is, we have epsilon and 576 by epsilon, where epsilon should be greater than 0, first condition, so that these two values will be positive. But the problem is, the last element of the first column is already minus 48. So there is one sign change which will happen if we consider epsilon greater than 0. Then we see that the roots lying on the right half of S plane will be equal to one root. Therefore, we all know that if any root lies on the right half of S plane in S plane, then the such system is considered to be unstable. So the given question is literally unstable. So in this problem, we were able to see two cases. One is case 1 and also case 2. So irrespective of the condition they might arise. See, we got case 2 first in this problem, and then we saw case 1, okay, which we got this element to be 0. Okay, first we got this entire row to be 0, and in second condition we got this element to be 0. So therefore both the cases have been arised in the same problem, and we were able to do the manipulation for those cases, and then we were able to find out the solution by considering or assuming epsilon being greater than 0, but still we were able to see the last element is negative. So at least there is one root in the right half of S plane. So therefore we say that the system is unstable. Okay, so this is what the answer or the solution for this particular problem.